Hello, welcome to the Ascender video where we're going to be looking at some A-grade revision topics starting with histograms. Okay, the first thing that you need to remember when we're looking at histograms is up our axes here. We do not measure in frequency, we measure in frequency density, or FD for short. FD. Okay, and we calculate the frequency density by doing our frequency divided by our class width. And we add a little extra column to our question here, frequency density. In this case, our class width goes from 0 up to 5. So it's going to be, and our frequency is 4, so we're going to have 4 divided by 5, which is 0.8. You should have a calculator for these questions, but if not, I advise getting to grips with your fifths. Here we have from 5 to 15, which is a class width of 10. Our frequency is 10, so it's going to be 10 divided by 10, which is 1. Over here, 24 divided by 15 to 30 is 15, and that is 1.6. 20 divided by 10, which is 2, and then finally 6 divided by 5, which is 1.2. And we need to work out what our scale is going to be on here. Let's have a look here. So I've got 5, 5, 15, 20, 25, 30, 35, 40. Great. So what I'm going to call is right at the top here 2, and we're going to go up in 0.25s, also 0.5, so that's 0.5. This is going to be 1, this is going to be 1.5. So each one of our little squares goes up 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, etc. Right up we go. And we just plot our class width right across from 0 to 10, and our frequency density was 0.8, so that's going to be 0.8, it's going to be, that's 0.9, that's 0.8, we're going to go along with a ruler. Okay, I just don't want to make this video really long, so I'm just going to do it freehand, but ruler, class width is 10, goes up to 0.8. Great, next one, class width is 2 seconds, sorry Miss Mina was distracting me. Class width is not 10. Okay, class width is from 0 to 5 and then up to 0.8. So 0 to 5 up to 0.8. I do apologise. 0.6, 0.7, 0.8. There we go. The next one goes from 5 to 15. So we're going to go 5 to 15, and our frequency density is 1. So it's going to go all the way up to here, and across. Great, etc. Continue it on. 15 to 30. So from 15 up to 30. Our frequency density is 1.6. Now I make 1.6 to be here, across, and down. Okay. Next column, 30 to 40, and we're going to do a frequency density of 2, so right up to the top of my scale. And finally, 40 to 45, and our frequency density is 1.2. 45 and down, and voila, we have our histogram. That's plotting one from a table. However, exams are very notorious at wanting to give us kind of half a table, half a graph, and we have to work back. And you'll see here that we have a graph of a histogram, and we have a table for that histogram, and we don't even have a scale for our frequency density. So the first job is to work out our scale. So we have to work out something that has already been plotted, which we do get in our table. So this first interval here, 0 to 20, sorry, 0 to 30, 0 to 30 doesn't have a frequency next to it, so we can't work out any information from that. However, okay, our 30 to 41 does. Our frequency is 35, so we can use that information to work out what the frequency density should be. And we can work out where that plots to on our graph. So, let's remind us, our frequency density equals the frequency divided by class width. So we're going to do our 35 divided by, or 30 to 40 is 10, so that's going to give me 3.5. So I know that where this bar goes up to here, this is 3.5 on my scale. And just having a quick look down, I can sort of have a little guess here. That must be 0.5. This is 1. 1, 2, 3, 4, 5. This is 1.5. This is going to be 2. 2.5. 3, 3.5, and then 4 right at the top here. So fantastic, we got a scale. So now we can pop ourselves back to working out what this bar should be in terms of working backwards. Now, working backwards is just a rearranging. Okay, we know what the class width is from 0 to 30, and we know that the frequency density makes it 1 here. We don't know what the frequency is, so we're actually looking for our frequency, and we just rearranging this. If we times both sides by the class width, times by the class width, I end up with my frequency equals class width times by the frequency density. That's a different way of looking at that formula. So in this case, my class width is, what's my class width? My class width from 0 to 30 is 30, times by my frequency density, which is 1, that's just 30. So my frequency is 30. Great. Done that one. That's already done and dusted. Okay. Looking at working backwards from here now, our 40 to 60 column. Our 40 to 60 column, our class width is 20. Times that by our frequency density, which is 3. So my frequency is going to be 60. Okay, a lot of people in there. And on to our next one here. We know what the frequency is, we know what the class width is, but it's not plotted on our graph. So the final thing we're going to need to do to complete this histogram is to plot our last two bars from this table. So working out what the frequency density is here and here. Now that this one's done. If you just want to take a second, I'll pause this video, have a quick go at that. You're going to be doing your frequency divided by class width to give you your frequency density. Have a quick go at that. Okay, welcome back. I hope that you had a good go at that. Your calculation should have been your frequency, 30, divided by your class width, which is 20, which will be 1.5. So we could plot from 60 to 80 up to 1.5 on our scale. Great, there's that one done. And finally, we have our 20 divided by our class width, which is 80 up to 120, so that's 40. Which is going to be 0.5, it's going to be a half. And then we plot that from 80 up to 120 and only up to half. And one quick thing to remember, that's all done now. One quick thing to remember about our histograms is that the area of these bars is actually the frequency. Our class width times our frequency density. So class width along the bottom times by the frequency density up. This is a rectangle, and the area of that is our frequency, and that's how we calculate things from histograms. So I hope that that was not too much of a drag for you. Just so you don't get bored of my voice on the other topics, we're going to pop over to Miss Mina. We'll have a go at that. Can we pause this?
Right, okay guys, it's Miss Mina here now. Right, we're going to go through this question. This is a different type of question, including percentages and a percentage of amount increase and decrease. So what we need to do is we've got £132.88. We're going to work out how much a percentage that is. So if we work out, we've got 100%, take away 12%. So we were left with 88%. So £132.88 is equivalent to 88%. Okay, right, so 88%, what is that equivalent to as a decimal? Make it a bit easier for ourselves. So that is equivalent to 0.88. So, I'm going to rub this out here. We've now got 0.88 here. Right, we want to work what this is going to be equal to as one whole, because that will give us our original 100% of the amount of the camera. So, how can we get from 0.88 to 1? We divide it by 0.88. How many 0.88s go into 0.88? And that is 1. So done it to this side, now I have to do it to this side as well. So if we divide 132.88 by 0.88 using a calculator, we get £151 exactly. So the normal price of the digital camera is £151. Okay, now I'm going to pass you back to Mr. Osmond to go through the next stage.
Hey guys, Mr. Osmond back, and we're on to a beautiful topic, which is vectors. Now vectors is beautiful, and there's two things I want you to think about when you're revising vectors, and that is firstly, we're always looking for long way rounds, i.e. have a look here, it's asking us to get from O to M, and we don't have anything that goes directly from O to M, so we've got to go right round here, our long way. Let's get my highlighter out, let's make this beautiful. We go from O all the way round up to P. O to M. Not O to P, that's my bad. Okay. It's even harder. Okay guys, don't make the mistake that I just did and just assume that's a normal vector question. We go from O to P. Actually no, we're going from O to M. We want to go from here up to here, but we can't actually get from there to one go. We can't even go the long way around. We can't even go from O to T to P and then down to M, because we don't have anything that goes, any vectors that connect us the whole way around. So actually we're actually going to have to look at, it says here that M is the midpoint of O to P. So we're going to do O to P, and we're going to have to find half of it. So it kind of is like that typical question. We're going to have to find just a typical long way round, O to T and then T to P, but then finally we're going to have to do half of that in order to get from O to M and B, wherever the arrow is. That's the second point. So the first point I wanted you to think of was a long way round. We can't go directly, we have to go around our vectors. And the second point I wanted you to think about was going with the grain or against the grain. Okay, make sure you know what's happening with these arrows. So first of all, I'm going to write down my journey. I'm going to go from O to T, and my arrow is with me. I'm with the grain. So I'm just going to write down my vector A. That's great. Vector A goes with it, and then I'm going up here and it's with my grain again. It's with the B, so it's plus B, and that's going to give me O to P. That's my journey. O to P is along here, along A, and then along B, so A plus B. But in order to get from O to M, that's got to be half of that. So I'm just going to call out half of A plus B is O to M, and that's your answer. Okay. Part B, express T to M in terms of A and B. Now let me delete my journey here. T to M, always our part B to get a little bit more complicated. Okay. T to M. Again, we can't go up here and then down here because there's nothing that goes from P to M, and we can't go back here and up there because there's nothing that goes from O to M, or is there? Okay, we've just worked out our O to M. That's there, and we can get from T to A. So actually we've got a nice, slightly simpler journey that we can take. Going from T, so guys remember, going the long way round with or against the grain. So we're starting at T, we're going backwards against our grain, so actually it's going to be a minus A. And then I'm going to go up and it's going to be with my grain, because originally I did go from O to M. So O to M is going to be plus this answer I've got from part A, which is great, but that's not quite in its simplest form. You can now almost think of it as algebra, even though they're technically vectors. You almost think of it just like algebra. We multiply out our bracket. We've got a minus A plus a half A plus a half B. And all I've done here is just multiply this bracket out here, because it's asked me to give it in its simplest form. If I had a minus A and I added on half of A, I'm going to end up with minus a half of A, but I'm still going to have my half B. I can't simplify that any further. And that's going to be my final answer for that. I apologise for making a mistake at the beginning, but it just goes to show even a genius mathematician makes mistakes, so take care in your exam. Great, this is going to be more of a normal question now, okay? Let's have a look here. Find vector A to B. So I'll tell you what, why don't you guys have a go at this part A quickly now. Hit the pause button. Okay, welcome back, hello. I hope you had fun at finding that. So to get from A to B, we're going to have to go down here, and then all the way along here. And we're going to end up from A to B. So that's how we're going to write that out. We've started at A, we've gone down to O, but we've gone against my arrow, so it's going to be a minus A, and then I've gone with my arrow to B, so it's going to be plus B. Perfect, just a nice quick answer there. And then we've got some awkwardness happening here. We're having ratios and stuff, and we're like, oh my gosh, what's happening with ratios? P is the point on AB such that AP to BP, PB, is in a ratio 3 for 2. I.e., in total here there's 5 parts. It's 3 parts and 2 parts, which means this is 3 parts long, that's 2 parts long. So we have to start thinking about fifths in total, and there you go, show that, there you go, fifths is popping up already. Show that OP is 1/5 of 2A plus 3B. Well, first of all, we just need to find out what OP is. So let me delete my old Jenny. This is going to be very similar to that last question here. I can get from my O to my A, I want my highlighter for this, I can get from my O to my A, but I can't quite get from my A to the P. There's no vector written down for me to get from A to P, but there is a vector for me to get from A to B, and that's what we worked out originally at the start. I can get from A to B, but I don't want to go all the way. Okay, I only want to go 3 parts out of how many parts total? 5, I hear you shouting. I'm grateful for that. Okay, 5 parts in total. We just want to go 3 parts, 3/5 in my big highlighter pen there. 3 out of the 5 parts down there. So I'm going to write out my equation here. So I'm going to do from O to A, so it's going with the grain, so it's going to be a plus A, and then I'm only going to do 3/5 of my vector AB, which we've got on my previous question. So if I substitute that in, that's going to be A plus 3/5 of, and I'm going to use my, what I found up here, that's going to pop itself down here, minus A plus B. And again, leaving it in its simplest form, and we kind of have an idea about what that's going to look like, because it says show that. It tells us what eventually it's going to look like. We just need to show that we can do the algebra to do that. Multiply out this bracket. We're going to be left with an A, multiply this bracket, so minus 3/5 of A plus 3/5 of B. And if I had A and I took away 3/5 of it, I'd be left with 2/5 of A. So 2/5 of A plus 3/5 of B, and I'm nearly there. Okay, let's bring all of this over here. Nearly there. It says to me it's a final form. We want a 5th on the outside as a factor. So actually, if I take a 5th out of all of this and put it on the outside of my brackets, okay, what do I need to times a 5th by to get 2/5 of A? Well, I need to times it by 2A. And what do I need to times a 5th by to get 3/5 of B? Times it by 3B. And actually, I end up with exactly the same answer as what they wanted me to show here. They wanted 1/5 2A plus 3B, and that's how we got it. And that's a very complicated part B question for vectors, so I really hope that you managed to follow that. And I'm going to pass the mic back over to Miss Mina.
Right, okay guys, Miss Mina again now. Right, this question is to do with bounds, okay? So the question says the length of a rectangle is 35 centimetres, correct to the nearest centimetre, and the width of the rectangle is 26 centimetres, correct to the nearest centimetre. And the question is then, calculate the upper bound for the area of the rectangle. Right, so first we need to find the upper bounds for the length and width of the rectangle. So upper bound of the length is going to be 35.5 centimetres. That is the upper bound. And then for the width, it's going to be 26.5 centimetres. That's the upper bound again. Okay, so it says calculate the upper bound for the area. Okay, so area is simply do this since you're really young. Area is just length times width for a rectangle. So you're going to do 35.5 times by 26.5, which on your calculator will show you as 940.75. Okay, this question also says to write down all the figures on your calculator display, okay? It's really important you do write down every single number that is on your calculator. This question hasn't got an answer space down here, so if it did it in the exam, make sure you write your units, okay, because that's 1 mark. If you haven't got the units in the answer space, you'll get an extra mark for that as well. Right, back to Miss Osmond again now.
Hey guys, back with me. We're going to do some trigonometry now, some of the advanced trigonometry. We're looking at the sine rule, the cosine rule, and the area of a triangle, and the formula for which is given to you at the beginning of an exam. Okay, if you ever get stuck in an exam and you're thinking, how on earth to work this out, have a look at the question, quick flick back through the formula book and just double check, see if any of those kind of pictures or words or equations look familiar that might actually help you in the question. So right now we've got this question here, work out the size of the angle marked x. If you answer correct to 1 decimal place. Now this isn't a right angle triangle. This is not a right angle triangle, and it's talking about angles and sides, and it's asking us to find things like that. It's going to be trigonometry, and it's going to be one of the harder trig ones. Okay, if it's a right angle triangle and we're talking angles and sides, it's going to be easier trig, soccer terror. But this is one of our harder trig questions. And the tip in spotting what's the difference between the sine rule and the cosine rule is that the sine rule will have a couple of angles involved. Either they'll give you 2 angles and they'll give you a side and they'll ask you to find the other side, or they'll give you 2 sides and an angle and ask you to find the other angle. Either way, there'll be 2 angles involved in the sine rule. So that's how we know that this one here is the sine rule. Now the equation they give you in the formula book is a over a sine of a is equal to b over sine of b, which is equal to c over sine of c. Now this works exactly the same upside down. I don't give it to you in the formula book, but we could say that sine of a over a equals sine of b over b, which equals sine of c over c. Now it's only worth using that when the thing we need to find is on top. It's a lot easier in terms of rearranging the equation and solving that when the thing we need to find is on the top, because we can just multiply by whatever's on the bottom and we're left with what we want on the top. If the thing we're trying to find is on the bottom, we have to do some weird multiplying by that thing and then dividing by the other thing in terms of rearranging, and that's going to be the hardest thing in terms of these questions. And the reason why I bring this up is because we've been asked to find an angle. Now the equation you get given in an exam has our sides, our a's, our b's and our c's on top, which is fine, but it means that when we're trying to find our angle, we're going to have to rearrange for something that's on the bottom. It's a lot more awkward. So do remember, if you can, that you can flip our sine a over a, sine b over b, and sine c over c to be equal to the same thing. It's not the same for all our fractions, it just happens to work for this. And I'd really urge you to work with that. Okay, and also try to ignore that, oh, a's and b's and c's, etc. We're just talking about big A is just whatever's opposite, whatever angle is opposite the side A, big B is whatever angle is opposite the side B, etc. So right here, I've got my side, my angle 30. So if I do sine of 30 and divide that by the side that's opposite it, which is 10, okay, that should be equal to my sine of this angle, sine of the angle I want, divided by the side that's opposite it, which is 12. Okay. We just want x on its own. That's what we want to find. So the first step of rearranging this is going to be timesing it all by 12. We had our sine of x, we had our x, we did sine to it, and then we divided by 12. We ended up with this over here. We just want x on its own. So times everything by 12. 12 times sine 30 over 10 is going to equal sine of x. Okay, and now this is one thing which hopefully you're a bit used to if you've been watching the blaster video and getting used to try and work out your normal trigonometry. We had x, we did sine to it. Now we need to undo that sign. So there's a button in the calculator which is usually shift sign, which is a little sine to the -1. And that sine to the -1 will leave us with x on its own. But we need to remember, we need to do that to all of this. Sine to the -1 of all of this, 12 times sine of 30 over 10. And the reason why I just want to make it look big and do it all in one go is that there's no rounding errors on your calculator when you do this. So we're going to do it all in one go. Type it all in one line. So I'm going to type in shift sign. So I've got inverse sine of, I've got my fraction, sorry, not my fraction yet, 12 times my fraction, which is sine of 30, and on the bottom is divided by 10. And I'm going to end up, press equals, 36.86989765, and always write out everything you can. And then we double check, how is it asking us to round it? 1 decimal place. So my first decimal place is here, cuts off here. Now, is it going to stay as an 8 or is it going to go up to 9? We'll look at the next number. Well, that's above 5, so it's going to go up to the 9. So my answer to that one is going to be 36.9 degrees. I was going to say centimetres then, just double check it is an angle we've just found. So it's going to be in degrees. That's great. I'm going to pop you over to Miss Mina again now. I hope you found that useful.
Right, okay guys, back to me now. Have a look at this question. It says, in triangle ABC, so here's our triangle over here, AC is 5 centimetres, BC is 8 centimetres, and angle ACB, so ACB is 75. Calculate the area of triangle ABC. So we know probably from year 7 that the area of a triangle is the base times the perpendicular height divided by 2. We haven't been given the perpendicular height, we've been given the lengths, 2 lengths of the triangle. So for this, we need to use this formula again, it's in your front page of your paper. So we know that the area equals half AB sine C. Okay, where AB here are the 2 lengths of the triangle given, and then sine C, so the angle C is the angle between the 2 sides that we've been given. That's really important to remember that bit. Right, so if we go back now to working it out, so we have the area equals a half times AB, so A is 5, B is 8, multiplied by sine C, so our angle is 75. So I'm going to make this a bit easier to work out. So a half times 5 times 8 is going to give me 20. So 20 multiplied by sine 75. So again, you need to use a calculator for this. So put that into your calculator and write down everything that's on your calculator. So you get 19.318516513. Okay, the question actually says though, give your answer correct to 3 significant figures. So, 3 significant figures, I'm going to look, 1, 2, 3. So it's going to stop there somewhere. So draw my line, have a look. This number is less than 5, so it means that this number is going to stay the same. So you're going to be left with 19.3. This is the area of a triangle, so you should remember this. You need to put in your units. So it's measured in centimetres, so we have 19.3 centimetres squared. Okay, back to Mr. Osman now then, guys.
Okay guys, I feel like I might be getting to that point in the video where it starts to be a bit of a drag, so I'm hoping to just whiz through this one really quickly, okay? Key points, this one is a triangle. It's not a right angle triangle, but it's talking about angles and sides and stuff, so we know it's going to be difficult trig. Okay, and the way to spot this from a sine rule question is that it's only got one angle and the sides either side of it. That's what it's on about. And it's asking us to find another side, so it's going to be our cosine rule. And the side we're trying to find is B to C, and that's over here, B to C. And I'm going to be really snappy. Just going to copy this formula out here. A squared equals B squared plus C squared plus minus 2BC times cos of capital A. And don't try not to get bogged down with all these little b's, little big c's, okay? Angle between them. This is our big A. Little a is obviously the one opposite it. Okay, it doesn't matter which one this b's or c's are, okay? So what we're trying to find are A squared. Our A squared equals, sorry, I just made a hand gesture, Miss Mina just reminded me that you can't see my hands on this. Okay, this is our A, okay? Great. A squared equals, don't know what that is, we're trying to find that. A squared is equal to B squared, doesn't matter, let's call that B. So it's 4 squared plus C squared, so let's call that C. C squared minus 2 times 4 times 6 times cos of our angle, which is 42. Basically, same as our triangle, it's the angle between 2 sides, the angle between them. So that's what all that goes in here, is our 2 sides, the angle between them, and that gives us an A squared. We just want A, so we're just going to have to do the square root of all of that. And guys, again, I'm just leaving it as one big thing. I'm not going to write it all out to waste your time. Okay, I'm going to type it into my calculator. So there's no room for rounding errors on our calculator. Just do it in one big calculation. 4 squared plus 6 squared. This is all happening all in one line on my calculator. 2 times 4 times 6 times cos of 42 close that bracket, press times, and again that will give me 4.0409 blah blah blah, and it wants it to 3 significant figures, so I'm going to go 1, 2, 1, 2, 3. This is our third significant figure. I'm going to draw a line after it. Is it going to stay as a 4 or go up to a 5? It's a 0 after it, so it's going to stay as a 4, so it's going to be 4.04 centimetres, and that's going to be our answer. I hope that was speedy enough for you. Let's pop back to Miss Mina.
Right, okay guys, back to me now. Right, have a look at this question. This is about samples and stratified sampling. Okay, so first question says, work out the number of male students studying Spanish in the sample. So we want Spanish students that are male. So if we have a look at that bit there, we've got 26. So there's two ways you can do this. We can do our sample size that we've got. So if we look at the question, it says 50 of the 258 students is taken. So we've got a sample of 50. We can divide that by the total. So the total is 258. So divided by 258. We multiply it then by the individual category. So we've got male studying Spanish is 26, and we multiply that by 26. Okay, and that will give us an answer of 5.03875,969. Okay, so that's the first way we can do it. Okay, so that is, okay, obviously we can't get 5.0387 male students studying, so you have to round that one, and we can round that to 5, so it's 5 students. Okay, so we draw a line, we're going to do it to one whole number, so that's going to round to 5. Other way we can do it is taking our individual, okay, so we've got 26, we can divide that now by our total, which is 258, and then multiply that by our sample size, so it's multiplied by 50. And obviously we just rearranged these numbers here, so we get this exact same answer, so you don't have to work that out. So I know that will be 5 people again. Right, bottom one then. Work out the number of female students in the sample. So I want now number of female students. So female students, we had some doing German, some doing French, and some doing Spanish. So first of all, we have to add all the females together. So we have got 25 plus 48 plus 62, and we are left with 135. So that's our total number of female students in the sample overall out of the 258. So what we need to do now is exactly as we did before. So we've got 135, which is our total of girls, divided by the total amount of students, which is 258, multiplied by our sample size. So multiplied by 50. For that one then we get 26.1627907. That's on my calculator. Obviously you can't get 0.16279 of this person, so if you round that, okay, we want to round that to a whole number, that's less than, so it's going to become 26. Again, you can do the exact same if you want as we did up here. You can rearrange it, so we can have 50 divided by 258 multiplied by 135, which will give you the exact same answer as over there as here, and you will get 26. Okay, back to Mr. Osmond now then.
Hey guys, we're on to a bit of a tricky topic now, which is proportion. We're talking about direct and indirect proportion. Here it says proportional, and it doesn't say inversely proportional, it doesn't say directly, but when it's just proportional on its own, it means directly proportional. And an initial formula that I'd like you to think of all the time, okay? The mass, m, is proportional to the cube or its radius. So whatever it is over here, cube or its radius, that's the radius cubed. The mass is proportional to the radius cubed, and that means it's equal to something times the cube of its radius. And that's all it means, but we need to just have m and r as our only unknowns. We need to work out what that k is. But that's our general formula for when it's directly proportional. Our something equals k times whatever it's proportional to. And similarly, if I skip forward to the inversely proportional question, okay, again, P is inversely proportional to just V in its own. It's not V cubed now, it's just V in its own. But because it was inversely, it's not K times it, it's 1 over K times it. Exactly the same layout, it's just this time it's inverse, so it's 1 over K times it. And the previous one, this one here, is K times it. And they give us some initial conditions which help us actually work out what that K is. It says that R is 5 when M was 3,750. So let's plug those in for now. So this is our kind of formula as we want it. We're going to have to play around with some numbers to work out what that K is. So 3,750 equals K times R cubed, 5 cubed. Okay, so 3,750 equals K times 125. And I don't want K times 125, I just want K on its own. So if I divide by 125, then I'm going to end up with 3,750 divided by 125, 30. My K equals 30. And we're not quite done yet. That has got to get plugged back into here. So my final formula is M equals 30 times the radius cubed. And that is my answer to that first part. And let's quickly pop over and have a look whilst that's still fresh in our heads. Let's pop over to inversely proportional. Again, we have our initial conditions. Okay, this is our formula. We just want K on its own. No, we need to work out what K is, so we've got P and V on its own. So P is 5 equals 1 over K times when V is 8. Okay, we need to rearrange this to get 1 over K on its own. So we divide both sides. We don't want that times by 8. So we're going to divide by 8. Okay, which is going to give us 5 divided by 8 equals 1 divided by K. And that's all I'm going to do. I don't need to do anything more there. I'm just going to take that. My 1 divided by K is going to get put back in here. So I'm going to end up with my P equals, my 1 divided by K is just equal to 5 divided by 8. So 5/8 of V. And that's my final little formula. Okay. Popping back, this is pretty much all these questions always laid out just like this. It asks you to put it in a formula where we have to worry about our K's and stuff. K just means constant, in probably a German constant, I guess. I don't know. K just means a constant number, so it's always 30 no matter what M or R are. And then finally, this is just putting stuff into a formula. When R is 6, what is M? Well, M is going to be 30 times 6 cubed. It's literally as easy as that. These second parts. 30 times 6 to the power of 3. In my calculator, 6,480. That's going to be my answer. Okay, kilograms. If you can remember, M is in kilograms. Don't forget your units all the time. Put it back over here, we're going to have an equally easy sort of finishing to do here. Calculate P when V is 2. Well, P equals 5/8 of 2. So 2 times 5/8 in my calculator is going to give me 1.25, and so there isn't any units in here in the question. I can't see any units, so that's just my answer, 1.25. Now it's quite a difficult topic. I'm hoping that that should hopefully help you revise for that, but I'm going to pop you back to Miss Mina to go on to our next topic. Only a few more to get through, guys, so bear with it, okay? I know we've been just over half hour, but keep going, keep marching through.
Right, okay guys, me again, but the last one with me now. Okay, this sort of question came up in your paper as well. It should say, which Mr. Osmond hasn't written down, solve. So solve 3x squared plus 5x minus 4. Mr. Osmond and I have tried it. You can try it till you're blue in the face, but it won't factorise to 2 brackets. So you're going to need to use the formula. The formula is on the front page of your paper, and it says that for a quadratic formula in the form ax squared plus bx plus c equals 0, we can use a formula where x equals minus b plus or minus square root of b squared minus 4ac, all divided by 2a, which will give us our 2 solutions for x. Right, so we have x equals minus b, so we've got the minus number there. B is equal to 5, so we've got minus 5, plus or minus. The plus or minus are there so that we will get two solutions at the end of these calculations. So it's a square root now of b squared. So b is 5, so it's 5 squared there, and then take away 4 multiplied by a, which is 3 multiplied by c. Now c here is minus 4, so be careful of that because it states in there that it's plus c. This is minus 4, so it's minus 4 there. Then that is all divided by 2a, so it's 2 multiplied by 3. Okay, now let's simplify that a bit more. So we've got minus 5 plus or minus the square root. You can do this whole bit here in your calculator now, to be careful with your minuses. And I make that to be 73. And that's all divided by 2 times 3, which is 6. So now we can move to our two separate solutions. So we can either have x equal to minus 5 plus the square root of 73 divided by 6, or we can have x equal to minus 5 take away the square root of 73, all divided by 6. So you can put in your calculator. For this one here, you will get 6.59066720909, and then for this one over here, you would get minus 2.257333958. Unfortunately, the genius that is Mr. Osmond hasn't written how he'd like the answer, so we're going to do it to 2 decimal places. So, 2 decimal places, put your line in, it's going to be there. So 0 is less than 5, so it's going to stay the same, it's going to be 6.59 to 2 decimal places. And then this one over here, put your line in, 2 decimal places, is going to become minus 2.26 now, because the 7 is going to round up to 2 decimal places. Well, that's the last one for me now, guys, so back to Mr. Osmond.
Hey guys, so we're on to our final question. Big breath. Final topic in our grade A revision video. Well done for getting through this far, and this is going to be Pythagoras in 3D. Now, Pythagoras. C squared equals A squared plus B squared. Okay, and if you watch one of the previous videos on the blaster, or I think it should actually be on the C. What's C? What's the C video? The Crammer. That's it. If you watch the Crammer, I think Pythagoras should maybe be on the Crammer, because it is a C grade topic just about. For normal Pythag, the thing is now we've got a bit of a weird Pythag going on, okay? We need to find B to G, so that's on the bottom left hand corner of this cuboid, right up to the top right hand corner. So suddenly we've got this kind of line going down here, and I'm going to draw my triangle in green. I've kind of got this kind of dot 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 going diagonally through from the bottom left corner to the top right corner, and because it's going diagonally along from the bottom left to the top right corner, the base of this triangle is also some funky green stuff happening there. It's also going to go along here, and we're going to have our height of our triangle, and this is going to be our right angle, and visualizing this is the hardest part. It's what makes it an A-star question. We have a kind of slice, imagine a little slice going through here. It's a right angle triangle. I just did a gesture with my hand, and obviously you can't see that, I apologise. Okay, we're a slice going through our triangle there, and that green triangle, if I draw my green triangle out to the side here, okay, it has a little right angle down here next to H, has a G up here, and has a B down here. Great, and we need to find, this is our big question, we need to find that. And we know that the height of it is 5 centimeters. Okay, and we don't actually know what that base is, so actually we're going to have a different triangle going on. Let's call it pink, let's get a pink triangle out. Okay, and my pink triangle is going to help me find this bottom length, this bottom diagonal here. Okay, and if you imagine that's a kind of right angle triangle laying down on the base, and if I draw out my triangle here, this is what it would look like. It's going to have B at the top, D at the bottom, and it's going to go right along here to H. And this side is going to be 8 centimeters, 6 centimeters. Okay, and I know just because I've been revising my Pythagorean triples, that's going to be a 6, 8, 10 triangle. In terms of my hypotenuse is going to be 10. But if you, in case you didn't know that, let's just do 6 squared is 36, 8 squared is 64. If I do 36, add 64, which equals 100, and if I square root 100, I get 10. Okay, great. So I now have my B to my H. I know that that is 10 centimeters. Boom, that comes along here. And I'm on my final side now. I can now find out what my X equals. Okay, let's use a bit of a darker green so we can actually see. I know that my X squared is going to equal my B to H, which is 10 centimeters squared, plus my G to H squared, 5 squared. So it's going to be 100 plus 25, which equals 125. That's going to be my X squared. The thing is, I want X on its own. So X is going to be the square root of 125, which is going to be 11.180339959, which, rounding it to one decimal place, sorry, 989. Thank you, miss. Okay, rounding that to one decimal place, 11. It's actually going to go up to 2, isn't it, that one? 11.2 to one decimal place. And we're talking centimeters, don't forget our units, okay? Well done, guys, you made it through the Ascender video. These aren't every single topic you need to know for your grade A, but this is pretty much most of them and all the chunky ones you need to do. I really hope it was helpful, and good luck. Miss Mina, you need to stop the video. Stop, no, not